There is a $40 barrel sitting behind a house right now that is doing something that should be impossible. It is eating grass, lawn clippings, the same grass you mow every Saturday, rake into a pile, stuff into a plastic bag, and throw away. That barrel is eating it, digesting it, and producing the exact same gas that flows through the pipe into your kitchen stove. The exact same gas that heats your water. The exact same gas that fires up your furnace in January. The exact same molecule, CH4, methane, and that barrel has no engine, no motor, no fuel tank, no electrical connection, no solar panel on top, nothing. It is a sealed plastic drum filled with wet grass, and it is generating combustible fuel 24 hours a day using nothing but bacteria that have existed on this planet for 3.5 billion years. And this is not new. This is not some startup pitch. This is not a Kickstarter that raised $4 million and disappeared. The first version of this machine was built in 1859. At a leper colony in Bombay, India, a British engineer sealed human and animal waste inside an airtight chamber, captured the gas that rose off the rotting material, and used it for lighting and heating. That was 167 years ago, 17 years before Alexander Graham Bell made his first telephone call. And that technology, that fundamental principle of trapping decomposition gas and burning it for energy, is the same science inside that $40 barrel in somebody's backyard right now. So why does nobody have one? Why are 132 million American households paying an average of $75 a month for natural gas when the same molecule is being produced for free in every landfill, every compost pile, every swamp, and every cow stomach on Earth? Let me explain what is actually happening inside that barrel. When organic material decomposes without oxygen, a specific class of ancient microorganisms called methanogens goes to work. These are not ordinary bacteria. Methanogens are archaea. They are among the oldest life forms ever found on this planet. They predate complex life by billions of years. They evolved in a world that had no oxygen, and their entire metabolic function, their entire reason for existing, is to eat organic acids and hydrogen and excrete methane. That is what they do. That is all they do. They eat waste and they produce fuel. The process happens in 4 stages. First, hydrolysis. Enzymes break down complex organic material like grass clippings into simple sugars, amino acids, and fatty acids. Second, acidogenesis. A different group of bacteria converts those simple molecules into volatile fatty acids, alcohols, hydrogen, and carbon dioxide. Third, acetogenesis. Another group converts the fatty acids into acetic acid and more hydrogen. Fourth, methanogenesis. The methanogens consume the acetic acid and hydrogen and produce methane and carbon dioxide. That mixture, roughly 50 to 70% methane and 30 to 40% CO2, according to the Environmental and Energy Study Institute, is called biogas. It is flammable. It burns with a blue flame. And it can cook food, heat water, or run a generator. Now, here is where the numbers start to matter. According to Mother Earth News, a well-managed digester produces approximately its own volume of biogas each day. A 55-gallon drum, properly fed and maintained, produces roughly 55 gallons of biogas daily. That is about 7.5 cubic feet. Feed it consistently with a mix of grass clippings and kitchen scraps, and that number can climb. Fresh grass clippings produce approximately 1.5 cubic feet of biogas per pound. If you mow your lawn and collect 20 pounds of clippings, that single mowing produces 30 cubic feet of biogas after digestion. 30 cubic feet is enough for roughly 1 hour of stovetop cooking. One mowing, 1 hour of free cooking gas. Over a growing season, that lawn produces 2,400 to 3,200 pounds of clippings, depending on climate, grass type, and mowing frequency. At 1.5 cubic feet of biogas per pound, your lawn alone generates 3,600 to 4,800 cubic feet of biogas per year. At roughly 30 cubic feet per hour of cooking, that is 120 to 160 hours of free cooking fuel annually, just from grass. Add kitchen food waste from a family of 4, roughly 2 to 5 pounds per day year-round, and you are approaching enough gas to replace most of your stove usage entirely. And here is the number that matters for electricity. 1 cubic meter of biogas, which is about 35 cubic feet, produces approximately 2 kilowatt-hours of electricity when run through a small generator. Your annual grass clipping biogas production alone could generate 200 to 275 kilowatt hours of electricity. Add food waste and that number doubles. A small household digester, fed daily with a combination of grass, food scraps, and garden waste, can realistically produce 1 to 3 kilowatt hours of electricity per day through a converted generator. That is not theoretical. That is math. Published, peer-reviewed math, confirmed by research institutions from Penn State to the Indian Institute of Technology. 1 to 3 kilowatt hours per day does not sound like much until you realize what it can run. A standard LED bulb uses 10 watts. 1 kilowatt hour runs 100 LED bulbs for 1 hour, or 10 LED bulbs for 10 hours. A phone charger uses 5 watts. 1 kilowatt hour charges your phone for 200 hours. A small DC refrigerator designed for off-grid use runs on 50 to 70 watts. 1 kilowatt hour keeps it running for 14 to 20 hours. If your barrel produces 2 kilowatt hours a day, you can run lights, charge devices, and keep a small fridge cold. From grass. Now let me tell you the history, because this is where the story turns from interesting to infuriating. In 1776, Alessandro Volta was sailing on Lake Maggiore in northern Italy. He noticed bubbles rising from the muddy shallows near the reeds. He collected the gas in bottles. He tested it. He discovered it was flammable. He had just discovered methane. The man whose name we literally use for the volt, the fundamental unit of electrical potential, discovered the molecule that could decentralize energy for every household on the planet. He found it rising from a swamp, a natural biogas reactor that had been running for millions of years without any human intervention. 63 years later, in 1859, the first engineered biogas plant was built in Bombay. By 1895, the city of Exeter, England, had scaled the technology to municipal infrastructure. Engineers captured biogas from a sewage treatment facility and piped it directly into the city's street lamps. An entire district of Exeter was illuminated at night by gas produced from sewage, not coal gas, not kerosene, human waste, processed by bacteria, burned for light, and it worked perfectly. Fast forward to the 20th century. India recognized that cow dung, which is available in staggering quantities across rural villages, is an ideal biogas feedstock. The Indian government launched the National Biogas and Manure Management Program. As of today, over 5 million household biogas plants have been installed across rural India. 5 million families cooking every meal on gas produced from cow dung in a concrete digester behind their house. No pipeline, no utility bill, no monthly payment, just a sealed chamber, some manure, and bacteria doing what bacteria have been doing since before dinosaurs existed. China went even bigger. Over 27 million household biogas plants have been installed across rural China. 27 million. That is not a pilot program. That is not an experiment. That is a national energy strategy built on the back of a $40 technology. Germany took a different approach. Instead of household units, Germany built over 10,000 commercial biogas plants that feed electricity directly into the national grid. According to Eurostat data, Germany generates over 33 billion kilowatt hours of electricity per year from biogas. That is 5% of the country's total electricity, not from solar, not from wind, from rotting plants and manure. 5% of one of the largest economies on Earth is powered by the exact same process happening inside that barrel. In Rwanda, prisons installed biogas digesters that process human waste from inmates and produce enough cooking gas to feed the entire prison population. Firewood consumption dropped by 85%. In Kenya, schools run cafeteria waste through digesters to generate cooking fuel for hundreds of students. In Nepal, over 300,000 household digesters have been installed through government subsidies. In Vietnam, Cambodia, Ethiopia, Tanzania, Bangladesh, the list goes on and on and on. Tens of millions of families around the developing world are generating free fuel from waste, and the average American has never heard the word biogas. Now, follow the money. The United States natural gas pipeline infrastructure represents nearly $200 billion in investment, according to Global Energy Monitor. An INGAA Foundation study projected that an additional $1 trillion in new pipeline investment will be needed by 2052. That is $1.2 trillion in infrastructure built to move a molecule from a hole in the ground to your stove, a molecule that your lawn produces for free. Your monthly natural gas bill of $75 feeds a supply chain that includes drilling companies, fracking operations, processing plants, pipeline operators, distribution utilities, meter readers, billing departments, customer service centers, and shareholders who demand quarterly growth. Every single one of those entities exists because you pay for a molecule that is available for free in your backyard. A $40 barrel threatens every single one of them. And here is the environmental kicker. According to the Environmental Defense Fund, methane is more than 80 times as potent as carbon dioxide at trapping heat in the atmosphere over a 20-year period. When your grass clippings decompose in a landfill, the methane they produce rises into the atmosphere and accelerates climate change at 80 times the rate of CO2. When those same clippings decompose in a sealed biogas digester, the methane is captured and burned. Burning methane converts it to CO2 and water, which is still a greenhouse gas but 80 times less potent. By capturing and burning biogas instead of letting it escape from landfills, you are simultaneously producing free fuel and reducing greenhouse emissions. The EPA's own data shows that landfills are the third largest source of human-related methane emissions in the United States. 13 million tons of yard waste went to American landfills in 2021, according to Mother Earth News citing EPA data. 13 million tons of free fuel dumped in a hole, producing methane that escapes into the atmosphere and warms the planet, while 132 million households pay for the exact same molecule piped from a fracking well. Now let me tell you exactly how to build this. Go to a hardware store, buy a 55-gallon plastic drum with a sealed lid. Cost is about $15 to $25, or free if you find one on Craigslist or Facebook Marketplace. Buy a 10-foot length of 3/4-inch PVC pipe, a PVC ball valve, 2 PVC bulkhead fittings, a tube of silicone sealant, a few feet of flexible gas tubing, a pack of steel wool. Total additional cost is $15 to $20. Drill 3 holes in the drum, one near the top of the barrel for the gas outlet. Fit a bulkhead fitting and connect your PVC pipe leading to the gas collection line, one on the upper side wall for the feeding inlet. This is where you add fresh material. Use a wide PVC pipe at least 3 inches in diameter with a screw cap so you can seal it after each feeding. One near the bottom for the effluent drain. Fit a bulkhead fitting with a ball valve so you can drain spent material periodically. Seal every connection with silicone. No air must enter the system. Anaerobic means without oxygen. If air gets in, the methanogens die and you get compost instead of methane. For gas storage, the simplest method is an inverted bucket in a tub of water. Run your gas outlet tube into the water and up into the inverted bucket. As gas accumulates, the bucket rises. When you want to use the gas, flip the valve and the weight of the bucket pushes gas through the line to your burner. Cost for this setup is essentially zero if you have a bucket and a tub. Before the gas reaches your burner, run it through a scrubber. This is critical. Biogas contains hydrogen sulfide, which smells like rotten eggs, corrodes metal, and is toxic in high concentrations. The scrubber is simple. Take a short section of wide PVC pipe, pack it loosely with steel wool that you have let rust for a few days by spraying it with vinegar and water. The iron oxide on the steel wool reacts with hydrogen sulfide and removes it from the gas stream. Replace the steel wool every few months. Total scrubber cost is about $2. Fill the drum 3/4 full with a slurry of chopped grass clippings and water. Ratio should be roughly 1 part grass to 2 parts water by volume. The mixture should be the consistency of a thin smoothie. If this is your first batch, add a starter culture to introduce methanogen bacteria. The easiest source is fresh cow or horse manure, about 1 gallon. If you do not have access to manure, pond, mud, or ditch sediment works because methanogens are abundant in any anaerobic aquatic environment. Seal the drum, place it in direct sunlight or inside a small greenhouse structure to maintain temperature above 70 degrees Fahrenheit. Optimal temperature for mesophilic digestion is 90 to 105 degrees Fahrenheit. Within 7 to 14 days, gas production begins. You will see your collection bucket start to rise. Test the gas by carefully lighting a small burner connected to the gas line. If you see a blue flame, you are producing biogas. If the flame is yellow or does not ignite, the methane concentration is still too low. Wait a few more days and test again. Feed the digester regularly. 3 to 5 gallons of mixed organic waste per week for a 55-gallon system. Grass clippings, food scraps, vegetable peels, coffee grounds, stale bread, leftover rice, fruit that went bad, garden waste. Do not add meat, dairy, or oils in large quantities, as they produce excessive hydrogen sulfide and can inhibit methanogen activity. Do not add anything that has been treated with herbicides or pesticides, as the chemicals can kill the bacteria. Drain effluent from the bottom valve every 2 to 4 weeks. This liquid is rich in nitrogen, phosphorus, and potassium. Research published in Cambridge's Renewable Agriculture and Food Systems journal confirmed that biogas digestate contains a balanced nutrient profile that performs comparably to commercial NPK fertilizer. Pour it on your garden. You now have free fuel and free fertilizer from the same barrel. Now the safety section, because I am not going to pretend methane is a toy. Methane is flammable at concentrations between 5 and 15% in air. An improperly sealed digester can leak gas that accumulates in enclosed spaces and ignites. A 2024 study published in Safety Science analyzed biogas plant accidents and found that explosions accounted for 69% of all reported incidents. Penn State Extension specifically warns about the risk of explosion when air mixes with methane inside a digester, particularly during maintenance. Rules for safe operation. Build and operate the digester outdoors, away from your house, garage, and any structure. Never open the digester near an open flame. Install a pressure relief valve on the gas line so pressure cannot build beyond safe limits. Use a flame arrestor between your gas storage and any burner. This is a small metal mesh insert that prevents a flame from traveling back up the gas line into the storage container. Never store biogas indoors. Never smoke near the digester. Check all connections for leaks regularly using soapy water. If you see bubbles, you have a leak. Fix it before using the system. If you follow these rules, a small backyard digester is no more dangerous than the propane grill sitting on your patio right now. Propane is also flammable. Propane also explodes if mishandled, and nobody panics about propane grills. Let me put this in perspective. 40 million acres of managed lawn exist in the United States. That makes turfgrass the single largest irrigated crop in America. We water it, we fertilize it, we cut it, and then we throw it away. 13 million tons per year sent to a landfill, where it produces methane that escapes into the atmosphere. While you pay $75 a month for methane piped from a well in Oklahoma, India figured this out. 5 million digesters, China figured this out. 27 million digesters, Germany figured this out. 33 billion kilowatt hours per year from biogas. Rwanda, Kenya, Nepal, Vietnam, Cambodia, Bangladesh, Ethiopia figured this out. Tens of millions of households producing free fuel from waste. America has not figured this out. Or rather, America figured it out a long time ago and then buried it under a $200 billion pipeline. Network and a monthly gas bill that nobody questions. A $40 barrel, some PVC pipe, some grass, some water, some bacteria that are older than oxygen itself. That is all it takes. The methane molecule does not know whether it came from a fracking well or a barrel of wet grass. It burns the same, it heats the same, it generates electricity the same. The only difference is who gets paid. When it comes from a pipeline, shareholders get paid. When it comes from your backyard, nobody gets paid. And that is exactly why nobody told you about it. Your lawn is not a chore. It is not a waste product. It is not something to be bagged and forgotten. Your lawn is a fuel source. It always has been. And every single week, you mow it, bag it, and throw it away. You are throwing away free energy and writing a check to a corporation that sells you back the same molecule at a $900 annual markup. Stop throwing it away. Start feeding the barrel.